What's up, my first class Falcons? This is one of the last assignments that you are getting for 7th grade. Are you excited? So first, let's talk about what is volume. Volume is how much you can put inside a 3D figure. So like if you bought a 2-liter soda, 2 liters is talking about how much liquid is inside of it. Or some of you guys might be filling up your pools. So we're talking about how much water can fill in your pools. All right, and then this is your general volume formula, base times the height. So if you find the area of your base for any prism, and again, a prism means that two bases are the same, times your height, that'll always give you the volume formula. So let's say it was a rectangular prism, right? Some of you guys might have heard this already, length times width times height. Well, guess what? This length times width part is really your base, right? So you could also write it again as your base times your height. So just keep that in mind with these problems. So we have this first question, find the volume of the triangular prism. So we have two bases that are triangles. And again, the way you find the area of a triangle is 1/2 base times height. And so we're finding the area of the triangles, 1/2 base times height. So our base is 4.2 and our height of our triangle is 2.8. And again, I know that these two triangles are our bases because there are two of them. All right, so again, that is our base. That is one of the triangles. The area of one of the triangles is 5.88 or 5 88/100. Now let's find the volume. And this formula works for every single volume problem with prisms. So let's fill it in. So we have 5 88/100 times 6. Okay. So we get 35.28 centimeters cubed. Again, volume is like how many cubes can fit inside of that prism. All right, and they didn't tell me to round anything, so let's check our answer. Well done. To the nearest cubic meter, what is the volume of the regular hexagonal prism? So our bases are hexagons. So we're going to use this formula to find the area of a hexagon. So we have our base, that's the same, times 1/2. Now, n is the number of sides, so we're times 6. S is the length of a side, which is 7. And then A is I forget the name of the word. What is it? Hold on. Apothem. Yeah, I was right. That is this little guy right in here. Okay, so that's 6.1. All right, let's use parentheses because the dots are a little confusing. All right, so we're going to multiply all those numbers together, and that'll give you the area of your base. All right, so your base is 128 1/10 centimeters squared. Now, again, we're going to use our regular volume formula, base times height. So we're going to use the area that we just found times our height, which is 14. All right, and you should have gotten 1,793 4/10 centimeters cubed. Now remember, make sure you write it as a whole number. So we are going to round down. Nice work. Number 3, this section of a concrete skateboard ramp has the shape of a triangular prism. Find the volume of the triangular prism. Then find the value of the concrete used in the ramp if the cost of concrete is $3 per cubic foot. Let's find the volume first. What are our bases? Our bases are triangles. How do you find the area of a triangle? 1/2 base times height. All right, and then let's fill in our bases and our heights. 1/2 base times height. All right, so our triangle's area is 18 feet squared. Now back to our volume formula, base times height. And again, I know this might sound a little confusing because your height is going this way, but remember, this figure can be turned around so that way the triangles are top and bottom, okay? All right, and then this is our answer. Let's check our answer. It doesn't say to round. 187.2. Check answer. Good job. Now they're going to ask us about the cost. So all we're going to do is take this number and multiply it by 3. All right, and you should get $561.60. All right, we're skipping over to question 5. A glass bead has a shape of a rectangular prism with a smaller rectangular prism removed. What is the volume of the glass that forms the bead? So we're going to find the volume of the outer part and then the volume of the inner part, then we will subtract. So our first volume is, and again, we could say that volume equals base times height, but again, with a rectangular prism, your base is length times width times height, which might be a slightly easier formula for you. So for this one, we're doing the outer part first, so we're going to use 6, 6, and 8. All right, so our outside part is 288 centimeters cubed. Now let's find the inside part. All right, same formula, and I'm actually going to use length times width times height. Again, length times width is the same as just saying your base because it is a rectangle. Actually, this is a square. So our volume is going to be length times width times height. Again, 8 stays the same, okay? All right, so our inner part is 128 centimeters cubed. Now all we're going to do is subtract the two of those numbers. All right, let's check our answer. There we go. All right, so this problem looks a little intimidating, but I think once you jump into it, you should be good to go. We have a cake has 2 layers. Each layer is a regular hexagonal prism. Again, so a hexagon means it has 6 sides. You cut and remove a slice that takes away one face of each prism as shown. What is the volume of the slice? What is the volume of the remaining cake? Use pencil and paper. Describe 2 ways to find the volume of each slice. So we're going to find the whole area of each prism. So again, let's start with V equals base times height, and I'm going to use the bigger one first, okay, the one on the bottom. All right, so I'm actually going to do this all in one step this time. So our base is a hexagon, and our formula is 1/2 times the number of sides, which is 6, the length of one side, which is 7, times the apothem, which is 6.1, and then times our height, which is 3. So I changed that into parentheses. I thought the dots and the decimals were getting a little bit mixed up. All right, and then we get our volume as 384 3/10 inches cubed. That's, again, that's the bottom part of our hexagon, okay, of our cake right here. So I'm actually going to erase some of this and put it off to the side, and then we're going to find the volume of the top part of our cake. Okay, so now we're looking at our top part of the cake. And again, this is still a hexagonal prism. So we're using the same exact formula. So let's fill it in again. 1/2 times the number of sides, which is still 6, the length of each side, which is also 6, the apothem, which is 5.2. Why do I keep doing this and using dots instead of parentheses? Okay. And then we're going to add in our height. This time we're going to just type this all in one step. All right, so that's the volume of the top part. So we're going to take the volume of the bottom part and the top part and add them up together. So when we add them together, we get 571 5/10 inches cubed, but that's for the whole thing. Again, so we're talking about only one slice. So again, they took a slice from one side out of 6. So we're going to take this number and we are going to divide by 6, and that's going to be our answer. All right, so again, it tells you round to the nearest whole number. So we have 95 and 25 hundredths, so we're going to round to 95. Let's hope this is right. I'll be upset. Nice work. So now the volume of the remaining cake is what? So again, we're going to take this number and we're going to subtract 95 from it. All right, so we got 476.5. And again, we're going to round that up. I actually did it already right here to 477, and we got the right answer. All right, so these are all the questions that I'm going to do for you right now. Again, if you have any questions about any of the other, if you have questions about any of the other questions, that sounds redundant, just let me know. Again, you send me an email. I know a lot of people's power was out before. If you have anything late, just send me a quick email. And I hope you all are doing well. I've been thinking about all of you.